This sort of panel came together because I had the opportunity to meet someone named Lehman Baird, who is the inventor of Hashgraph, which is a completely different, new distributed ledger technology, not blockchain. And I had Lehman on the program, and I was really sort of blown away by this technology, and I wanted to learn more about it. And there's sort of a lot of hype in the blockchain and crypto space around cryptocurrencies and everything else, and I thought this would be a really great opportunity to bring in something totally new, and an opportunity also to open it up to the audience to kind of learn what this technology is, how it's different than blockchain, how the protocol works, and kind of open it up to questions early on and get an opportunity to kick the tires on this. So why don't I let you guys first introduce yourselves. Mance, why don't you go first?
Sure. Hello, my name is Mance Harmon. I'm a co-founder with Lehman of Swirlds, which is the company that's commercializing the Hashgraph. Little background is I'm a computer scientist, couple degrees, most recently from UMass. Lehman and I actually started working together back, UMass? Lehman and I started working together back in 1993. We worked for the Air Force, senior scientist for machine intelligence, so our formal background is in machine learning. We also both taught computer science at the Air Force Academy. He's a full professor, or was a full professor there. I was head of cybersecurity. I was course director for cybersecurity. I managed a large software program for the Missile Defense Agency. I was told that I have to share this. So how many of you remember the movie War Games from the 1980s? Yeah. Yeah. So I managed the team, 160 people that actually built the real thing. And that was a lot of fun. And of course, it's now being used. It's the sim that's used for figuring out how to play these ballistic missile defense war games, so you know how to what the strategy should be for protecting the U.S. and our allies against missiles, right?
Very relevant conversation.
Yeah, thank you. Lehman and I started a company in the space of identity. We sold that company to a Fortune 500. I was the course director, I was the senior exec for product security for the same Fortune 500. We started another company in the space of identity. We sold it to private equity. Then I went to work for an identity player as the head of labs. I played, all right? I went to work as the head of labs for this organization, and was also the senior exec on staff for architecture, and got involved in this space. We started looking at blockchain for identity. Lehman, for the past 5 years, was trying to solve the problem that ultimately he was able to solve, we now call Hashgraph. And that was quite a journey. I guess the only other thing I should mention about Lehman is that he is a PhD from Carnegie Mellon in computer science. He has the notable distinction of setting the record for the history of the school and getting his PhD in the shortest amount of time, 2 years and 9 months for a PhD from CMU, which is quite a feat. And what we're going to talk about tonight is Lehman's baby. I wish he could have been here with us. We're not from New York City, we're from Texas. And so I've heard some people say, well, how can something like this come from Texas? It's a fair question. And as the evening goes on, you're going to hear my southern drawl get a little bit deeper and longer. My eyes are going to get a little bit longer as we go through this. We're Southerners from Texas, and glad to be here talking about the Hashgraph with the crypto community in New York City.
So I'm Jordan Freed, and I spent the last 6 years over in Budapest, Hungary, of all places, but I'm not originally a New Yorker, and I'm also new to the city. But I sort of came into the crypto space accidentally, in that the previous software company I ran, which was a virtual private network service, the #1 demand we had from our customers was accept Bitcoin as a payment method, and I said, what the hell is Bitcoin? So we integrated BitPay, we started receiving this Bitcoin, and it wasn't until the value went up that I started to really realize what this thing was. That company was acquired at the beginning of this year, and then my wife, who's here, can vouch for this, but I basically begged her to move to New York City to sort of figure out what to do next. And that's sort of where Andrew comes in and Dr. Baird. Dr. Baird's one of those guys you meet who you know your life will never be the same after you meet him. He's just one of those brilliant minds, and I think what he's invented here and what we're going to talk about is a testament to that. But I ended up making an investment in Swirlds, the company, and then couldn't help myself but drop everything and join the team full time to, I guess, really help take this thing from obscurity to the point where people know who we are. How many of you have heard of Hashgraph before this evening? Oh, wow, a fair number. Okay, so I hope that if we do this a year from now, that it's all of you. So that's my story.
Great. Oh, is this on? It is on. Okay. Oh, there we go. So I'm Andrew Masanto. I know a lot of people here, actually, a lot of friendly faces. Thank you for coming out. I'm inviting everyone to come and sit down at the front. There's tons of room, and it doesn't look as comfortable standing up, so please feel free to come on down and sit down at any point in time. I was traditionally a lawyer. I was trained in common law at the University of Sydney in Australia. Moved to London to work for an English law firm, same law system. And then while in London, I saw the sort of craze of the internet. I started a company called Altitude Shoes. It's still running right now, and I sold that. And then I got into internet marketing, started a company called Hire Click. That was at the beginning of the SEO and PPC boom. And I sold that, and Jordan, the way I know Jordan is, he took my place in the company. So he was the incoming, C-level executive that basically took my place, which you never kind of really have a great relationship with when someone's coming to take your place, even if you sell the thing. But that's how we first met, and a lot of really good companies were started, and there was the guy started TopTal was also working on stuff. So Jordan eventually left that company and started Buffer.com, which he sold this year, as you heard. Then I came to, I sold that company, went to LA, went to music school because I had enough of company building, thought I'd just retire for the rest of my life. Came to New York. And then I got an email from an MIT lecturer that saw that I was interested in. Had some interest in blockchain. I knew about the technology. I'm a bit of a mind geek, if you like. I like reading about stuff like that. And he introduced me to this concept called Hashgraph. So I had a call with Mance, and I was like, well, this is interesting. And I'd been investing in multiple things before. And then I really kind of went down this rabbit hole until I got to the very bottom, and I realized that this technology could be really transformational. And at that point in time, similar to Jordan, and similar to a lot of other people who have actually joined us, I was like, look, I really have to help this thing reach the light of day, because it is a technology that is ripe, that is meant to happen. Also, Lehman Baird, Dr. Baird or Lehman, is truly a spectacular individual. He's one of the most impressive people I've met, and a number of people who have met some extremely impressive people say that about him. Very humble guy, a consummate teacher, and he invented the Hashgraph after, from what I hear, going down many rabbit holes over 5 years and coming and realizing there were no rabbits in them. And then one day reaching down and pulling out the biggest rabbit you've ever seen, which I think this is. So that's my story.
Thank you, Andrew. Thank you, Mance and Jordan. So why don't we first start off with kind of an overview of what Hashgraph is, or what you think is so transformational about that, and then maybe we can double back and kind of explore the distinction between Hashgraph and blockchain within the context of distributed ledger technology, and then we can begin to focus on some of the transformational innovations with respect to Hashgraph, like the Gossip Protocol, how that's done, and virtual voting, and why that has allowed basically this explosiveness in terms of throughput on the network. I've done a back of the envelope calculation myself, and I've shared it with the guys here just in terms of this as a metaphor. And this network moves at roughly twice the speed of sound relative to the speed of a snail, if you want to compare it to the blockchain network in terms of speed. It's pretty remarkable, and it's hard to really put your mind around it when you recognize that fact. And it's also secure, very secure. And I want to talk about that too. So why don't you just give us a general overview of what Hashgraph is, and then we can sort of talk about those distinctions.
Sure. Well, so first of all, it's not blockchain, as already been stated. Blockchain as a term refers to both a data structure, a chain of blocks of transactions, as well as a consensus algorithm. An algorithm where a community of members who each have a copy of the chain can come to an agreement about what new block to put on top of the chain. They all put the same block on top of the chain, and so that the community can stay in consensus, stay in sync, so as it were. Hashgraph is not a chain. It's a graph, as you might expect. And the graph is created by each member of the community, contributing as they, at any point in time that they desire, transactions to the community. And the community receives transactions all the time. You know, every member, when they feel like it, submits a transaction to the community. That transaction flows throughout the community. Each other member of the community receives transactions, and they construct this graph that we will talk more about. And as new transactions flow on top of the graph and get added up or stacked up on top of each other, at some point in time, very quickly, the community comes to an agreement on the order of the transactions within this graph. That sounds like magic, and it looks sort of like magic, but it actually works very well, and we'll talk about how architecturally that works as we go through this. But the advantage of this approach is that, one, there is no proof of work, if you know what that means. It's not efficient, it doesn't have the inefficiencies that proof of work blockchain has. It's extremely fast because the members of the community can contribute transactions whenever they want, and the community all receives those and comes to consensus on the order very quickly. And it's not bottlenecked. There's no chain. It's a graph. And so we can achieve hundreds of thousands of transactions per second, for example, within a single peer-to-peer network. In scale, we can go to millions, or whatever you want to achieve in scale, with multiple shards, multiple networks of communities of computers. And it has security properties that are unmatched in the market.
You talked a little bit about blockchain there and about the chain. Can you go into a little bit more detail, sort of geometrically, what a blockchain is, so people can sort of understand that and what that significance is in terms of security, and in terms of how it relates to proof of work, slowing down the network in order to achieve a secure sort of consensus?
Let me sort of start with first principles so that everybody can understand. What is the point here, right? Let's talk about databases for a moment. When you have a database and you have an application that writes to the database, if the database accepts what we'll call write transactions, or transactions that change the information within the database, as well as read transactions that you read information from the database. If it accepts both, write and read, then it's definitionally a master database. And of course, these have been around for decades. The market then evolved to address concerns of redundancy and disaster failover and disaster recovery by creating a copy of a database to the side, perhaps, sort of conceptually, where every write transaction goes to the master, but then those writes also get replicated over to the slave database. You can read from the slave, the application can read from the slave, but the application can't write to the slave, okay? Then the market evolved a little bit, and it became possible for the application to write to both databases, both copies of the database. In this case, it's what we would call multi-master database. And there are some technical reasons why this is attractive, but this introduced a problem. And the problem is that if I have multiple users, if I'm the only one using the database and I'm the only one that's writing to either this master, master A, or master B, there's no problem. In reality, I'm not going to be the only one. There are going to be a lot of users, and a lot of users are going to be writing to both. And occasionally, the users are going to write to the same location in each. One user will write to, say, location number 3 in the first, and a different user will write to location number 3 in the second. And these databases somehow have to resolve this. We have to come to an agreement on the order in which these write transactions occur so that the databases can stay in sync. And then once we come to agreement, the databases apply those transactions to both, right?
Mance, just to clarify, what you're describing here is the need for distributed consensus.
I am getting there. That's correct. I'm describing conceptually what is this whole thing in blockchain about, right? It's all, and you can see that if we add more masters and more users, the opportunity for these write conflicts just goes up significantly. And most of the problem and most of the time is spent in resolving these write conflicts. In other words, for the community to come to consensus and agreement on the order of these write transactions to each of the masters. And once they have come to consensus or agreement, then they apply those transactions to each master database in the same order so the databases stay in sync. The assumption has always been, up until 2008, that one legal entity, one party, has administrative control of all the databases. Amazon, for example, would have control of all of the master databases in this multi-master system that manages their store. Amazon would never think to give Google a master from the Amazon cluster of databases. That, isn't something that ever occurred to anybody. What blockchain is all about is doing exactly that. It's giving masters away to other legal entities that may actually be competitive with you. They may, it's certainly not the case that you're all going to necessarily have your interests aligned. And so if it's the case that we're sharing this database and each one of us has a local copy and we're all writing to our local copy of the database and we're having write conflicts, we all have to come to an agreement on the order of the transactions and apply them in the correct order. Well, with that new security requirement, you have to then begin to think about a few types of attacks that you wouldn't otherwise think about. One is that no single party in our community should be able to change the order of the transactions, the history of the order of the transactions. This is what we would normally call immutability of transaction order. The other one is that no single party in our community should be able to execute an attack that would stop the flow of transactions across the community. Right? You wouldn't want one party to be able to do a DDoS attack, a distributed denial of service attack that could actually bring down the network. And then finally, it should be impossible for any single party to have the influence over the order of the transactions prior to the community coming to an agreement on the order of those transactions. In other words, it shouldn't be possible to bribe somebody to change the order of the transactions in your favor. This is what we call fairness. Okay? These are the fundamental concerns that arise when you move from traditional database technology, all run by a single party, to this multi-party database model where we're all sharing the data layer and we are maybe even unknown to each other. How do we protect ourselves from malicious attackers or people that want to do evil things? That's what the whole blockchain space is all about. Now, I didn't answer the question about blockchain. We can move on if you
I also want to mention one thing while you're speaking there, which is that the internet has been distributed communication for a long time.
Correct.
Of course, it has changed as it's scaled and there's intermediation and you have these large server systems. But what blockchain and distributed ledger technology attempts to do is to bring that level of disintermediation to the process of consensus, to the process of determining when and how a change has occurred in the network, where storage and how storage happens. So it's sort of like, anyway, I'll let you.
No, that's exactly right. So, I mean, if you think about this model, what we can do is have a shared database, and we each are running the same application on our local computers. And if the network, the rate at which we can process transactions and how quickly we come to agreement on the order of those transactions, if all of that is fast enough and secure enough, then we can begin to think about the anti-cloud, right? What is the cloud? The whole cloud movement is about having central servers that are running applications, SaaS applications, that we use our computers to connect to, and those central applications are providing the storage and providing the security, and we all have to trust that third party that manages it on our behalf. What we're talking about here is, for the first time, being able for each of us to run the same application. A good example might be World of Warcraft or some game, right? We each download the distributed equivalent of World of Warcraft. We install it on our local computer. We fire it up. And we are playing in this game, 1,000 of us, and the transactions that are being written to the state of the game are flowing throughout the community, and the math, the magic of the math, makes it possible for the system to totally be secure in ways that allows us to not have to have a third party running a server to make sure that we're not cheating, right? We no longer have to trust a central server. Cryptocurrency, of course. So in the world of cryptocurrency, we no longer have to trust a central bank. Okay, it's one sentence. We no longer have to trust a central bank to keep the ledger. The ledger is the database that we each have a copy of, and the magic of the math ensures that no single party can change the contents of that ledger, right? The community has to agree on the contents of that ledger. In other words, the community agrees on the order of the transactions that we apply to the ledger so that we all have a ledger that stays in sync.
Let me take a temperature read from the audience here. Do we need to go into blockchain itself a little bit and sort of get into more detail on that? No. All right. Okay, great. So we want to go right into Hashgraph.
Okay.
Okay. So, all right. So in that case, let's talk about the evolution. Let's get a little bit into sort of what makes Hashgraph unique. Now, we mentioned before blockchain, which has it's a chain-based system. There's proof of work, and there are other ways to sort of drive the consensus, but it's geometrically a very different system. Now, Hashgraph has two primary innovations, right, Manson? I don't know how you guys want to, if you guys want to jump in here or. Yeah, go ahead.
Yeah, so I think a way to look at this is when we talk about Hashgraph, a lot we talk about ushering in of what we feel will be the fourth generation of distributed ledger technology. So the first generation being Satoshi Nakamoto's white paper. I suspect that most of you are familiar with Bitcoin and what that introduced to the world, but that was distributed trust, this whole notion that we don't know each other, we're on opposite sides of the globe, but we can trust each other in, frankly, a trustless environment. And that was really revolutionary. Generation 2 was, what is this thing? It's a ledger. What else can we put on the ledger? Is it a title deed to property? Is that a stock certificate, and or is that a cryptocurrency? Is that value? And generation 3 became these smart contracts. How do we transact fairly with each other in this distributed architecture? How do I send you my cryptocurrency and you give me the title deed to your property, and we both know that that's going to happen? Yeah, Ethereum. And then generation 4 is markets and fairness. With all of this value coming on chain, we've got to now figure out a way to transact with each other fairly. So when we first introduce Hashgraph, or at least when I do, I like to introduce that property of fairness, in that we're talking about a whole new genre, a whole new world of applications that will be made possible because of this technical breakthrough. And it really is immense.
Define fairness for our audience in technical terms, what you mean by fairness.
So when I talk about fairness, I mean specifically, I'll go a little high level with this, but I mean specifically that we don't trust each other necessarily, and we need to know who came first in, let's say, a game. If you shot me before I shot you, that's got to register, and we all have to agree, we all have to come to consensus that that is the state of reality. And traditional architectures, in a gaming architecture today, you have a central server, and the winner of that would be the one that has the lower ping to that central server.
And the point is that to do that currently using a distributed ledger like blockchain is just too difficult because of the level, the latency of the network.
No. So when it comes to fairness, the requirement is that there's no single party that has the opportunity to influence the order of transactions prior to the point where the community comes to an agreement on the order of transactions. In blockchain, you have all the miners that collect all the transactions. They put them into a block, and then they compete with each other for the opportunity to publish that block to the rest of the miners to go on top of the chain. The problem is that the miners individually decide if a transaction goes into the block, so there's not necessarily fairness in access to the network. And number two, if they choose to put the transaction within the block, then they unilaterally determine the order of the transactions within the block. So they do influence the order that the community comes to agreement on of the transactions. Right? That's the fairness we're talking about. And Jordan is absolutely right. When it comes to games, which one of us actually pulled the trigger first makes a big difference. And so you need to be able to preserve the order the transactions actually flow into the network. That's the fairness property.
Or in a stock market, obviously, as well.
Or in a stock market
or if you're
trading
monitoring
platform.
traffic on a highway.
Or an auction.
And this is
right?
the gossip protocol. Because of the way that the network is gossiping the information, you're able to achieve fairness, correct? Let's talk, am I missing?
Yes.
It's not entirely it, but
Yes, yes.
I just,
There's- go ahead.
well, I want to get into this. These two real innovations on the gossip protocol, on the gossip side, in terms of gossiping about gossip, and the way in which you vote essentially virtually, which eliminates the entire sort of latency of a really robust network. Talk to us a little bit about how that. First of all, what does the graph look like? Because that's relevant here in terms of the creation of events over time across the network. Talk to us a little bit about that, the gossiping, and how quickly you can arrive at consensus, and the significance of the ability to arrive at consensus and to no longer need to ever look back in time, and what that means for the data on the network. Yeah.
Can I just say something really quick? You should answer that question, but I just wanted to add that the real innovation for me, Jordan saw the fairness. The real innovation for me was speed, to be honest. If you think about 1999, we were using 56K modems, and then you couldn't visualize where the internet would go, what applications would be available. When we received broadband fiber optic cable, this is why I'm excited about this, because the application use cases haven't been invented yet. I can think just from my mind's eye that there would be markets, there would be auctions, because you have fairness, because you have speed, there'd be games, but really the sky's the limit when you add speed to this network. So when I first discovered it, the most exciting thing for me was speed. Fairness was a necessary property to do some of these things. You're not going to compete in a stock market where you don't know that, where there's not a mathematically guaranteed fairness. Anyway, you guys, I've participated in ICOs before where I've sent money and I don't know if the miner is putting it before, but I don't get into these ICO deals, right? Because I'm not in control of the fairness, neither is the network. The miner determines who comes first. Anyway, so do you want to take it from there?
Yeah, why don't you answer that, and then what I want to do is, anyone who has, I want to open up the floor early to questions, because I know we got a lot of smart people here, and I want to give you all an opportunity to ask thoughtful, pointed questions, especially, so monitor yourselves. The more sort of thoughtful and pointed and relevant it is, feel free to sort of look out for that, and Genevieve will have a mic, and I'll look to see who wants to. Mance, go ahead.
Yeah, sure. So how does Hashgraph work? There is a category of consensus algorithms in the literature, the academic literature, that we refer to as pure voting-based algorithms. They have fantastic security properties. They achieve the gold standard of security from this world, the distributed systems world. It's something called asynchronous Byzantine fault tolerance, BFT, asynchronous BFT. The problem with this category of algorithms is that they are impractical in their bandwidth requirements. Conceptually, the way they work is that each peer, each member of the network, is asked to cast a vote on a question, and they all are asked to cast a vote on the same question, and when they cast that vote, the way in which they do that is by sending their vote to every other member of the network. And when every other member of the network receives a vote, they have to send an acknowledgement that they've received the vote to every other member of the network. And then there may be multiple rounds of this process that's required in order to come to an agreement on the order of a transaction or two. In other words, the bandwidth requirements blows up, grows exponentially fast in the number of votes that are required and then the number of peers that are in the network. For this reason, they aren't actually used in practice. There are no practical pure voting-based algorithm implementations at the scale that we need for what we're talking about here. The question then is, how do you achieve the same level of security and the fantastic theoretical properties without casting votes over the internet or over the network? And the way you do it is this. It turns out, and this is Leeman's moment of inspiration, this is his aha moment. What he realized is that where we started this conversation at the very beginning, we are each running a local copy of a database. And if these databases are going to stay in sync, then anytime there's a transaction that needs to be written to a database by anyone, those have to go to everybody. All transactions have to go to everybody. That's the minimum bandwidth required just by the laws of nature. It turns out that if you add a tiny amount of information on top of that, basically, if Alice talks to Bob and passes Bob a transaction that she's made to her local database, an update, if you will, and at the same time, she tells Bob who she spoke with last. If prior to talking to Bob, she received a transaction from Ed, then when she passes a transaction to Bob, she tells Bob, oh, I last spoke to Ed. And everybody does the same thing. It turns out you can take this information about who has spoken to whom, and you can chain it together in such a way that you have a picture of all of the communication that has taken place across the network. This communication that we're talking about is called gossip. And the picture is a picture of the gossip that has taken place across the entire network, and everybody has the same picture. We all get the same information, we all build up the same graph. This graph, by the way, is the hash graph. The hash graph represents the comm that's taken place across the network. And when we're passing the information about who we spoke with last, in other words, I'm gossiping to you about who I've gossiped with in the past. It's gossip about gossip. That's the hash graph. We take the hash graph and we use it as an input to one of these pure voting-based algorithms. We take the algorithm, we run it in our head, we use the hash graph as an input, and we're able to calculate for a given point in time what each member of the community would have voted if they were to have cast their vote over the network. But they don't have to. And because we're using the same hash graph and the same pure voting-based algorithm, we all come up with the same answer. In other words, we have consensus almost for free.
So, Mance, let me see if I can sort of wrap that up and see if I've got it right. What you're saying is that the entire network is sharing information. Each time it shares information, it's syncing up, basically. I come to you, I say, Mance, this is all the stuff I know, and you're like, this is all the stuff I know, and we fill each other in on the small things we don't know. Those are the transactions.
That's correct.
And
the transactions, along with the metadata of who I've talked to and when.
Right, the hashes.
Yes.
And the timestamp. And those are represented as events in memory, in the hash graph.
That's correct.
And that combined with the data that's stored locally in memory, there comes a point, and it takes between 0 and 3 seconds, if I understand correctly, where you have the hash graph to consult, essentially, and the data locally, where each node on the network can run locally a local voting algorithm and basically virtually vote and eliminate the entire bandwidth constraint and come to consensus asynchronous Byzantine fault tolerant.
That's exactly what I'm saying. And the important point here is that, so the little bit of information that I said we add on top of the transactions, technically what that is 2 hashes. So if that's meaningful to you, it's a tiny amount of information, and the hashes can actually be compressed. In other words, we achieve the bandwidth limit. I don't know how you do better than what we do in terms of bandwidth requirement. And because we're using a pure voting-based algorithm, we achieve the gold standard in security uniquely in the market. There is no other algorithm in the market that is practical that achieves asynchronous Byzantine fault tolerance, and we're fair. We're the only algorithm in the market that has a formal definition of fairness that is proven in the sense of math proof. Formally proven to the algorithm is formally proven to have this fairness property that I've described. I personally believe that Lehman has solved the problem of distributed consensus. And 100 years from now, there may be dozens of variants on the hash graph, but they will be on the hash graph because you cannot do better than asynchronous BFT, and you can't do better than the bandwidth limit of transactions with 2 hashes.
It's there.
Oh, it's there? Oh, there we go. Yeah, right. So in really basic layman's terms, the way I understand it, I'm not even the tech guy, but this is in my mind's eye. I've checked this with Lehman as well. If I gave all of you a piece of paper, all right, and it was cryptographically secure piece of paper, on this piece of paper, all right, there's a line. There's multiple lines because it's a whole graph, right? But there's a line from me to Dimitri, Dimitri to you, you to you, you to you. This is a singular line, right, which is cryptographically secure. So I can see the transactions he gave to him, he gave to him, he gave to him, and he gave to him, he gave to me, all right? Digitally signed, cryptographically secure. So we all have this same sheet of paper right now. We're all looking at this. Now, I need to know what you, and you would have voted for. This is the voting algorithm with regards to the transactions that the guy at the very end had, right? I didn't even have to talk to you guys because I know how you would have voted, how you would have voted, and how you would have voted, and how I'm going to vote, because you can't mess with the piece of paper, right? It's cryptographically secure. It's a hash graph. It's exactly what it is. And therefore, I know what consensus would have been if I had spoken to you. So you get consensus without even having to speak to anyone, which is why the bandwidth requirements are so low.
I'm curious if that really wows anyone, because when I did when I had Lehman on my program and I spent a couple days looking at the white paper and doing the best I could, really, I'm not an engineer, I was sort of just kind of dumbstruck. I couldn't understand it. And if you listen to the interview, there comes a point towards the end where that really becomes obvious, where I have that moment where I'm like, holy shit, like, looking for the magic trick, and I wasn't finding it. It was, So I'm just, if you're having that reaction, what I want you to do is essentially, if you think that you're having that reaction and you have a coherent question to ask, please do. Yes.
Hi, so this is very interesting and very new for me. I just wanted to ask with Hashgraph, what exactly is it that prevents the system from getting overwhelmed by bad actors? Because I always understood with Bitcoin security that the fact is that the system is so big, there's no bad actor powerful enough to overwhelm that system. And now correct me if I'm wrong, but based off what you said, it seems like Hashgraph, even if it's more efficient, has solved the scalability problem by dividing it into little sections. What's to prevent, if that is the case, what's to prevent people from overwhelming that? Like if we were at a poker game and it's me and 4 people trying to beat the one other person, like that person doesn't have much of a chance. So in this case, how would that analogy work?
Yeah. So there is a theorem, a math theorem, that says that it's not possible to do better than 1/3 of the actors in your population being evil. If they collude, if all the evil actors collude, then up to 1/3 of them can be evil, and you can still come to consensus. And that's not just true for Hashgraph, that's true in general. And so, yes, if you're playing poker and there are 5 of you and 4 of you are evil, then you're going to win. Right, that's going to happen. And so it's again, and it's not that this is specific to Hashgraph or in any sort of way, but the larger the population, the more secure that the system is as a whole, because it becomes more difficult. The theory is it becomes more difficult for to attract at least a third of the population being evil to collude. Now, I disagree with the premise, and this may be a little controversial. I disagree with the premise that Bitcoin is too big to be compromised, right? I mean, it is possible, hypothetically, for China to shut down the Great Firewall and partition the system, nationalize the miners, and kill the whole chain, right? They could just wipe it out if they chose to do so, technically, all right? And so, but again, it has nothing to do whether it's Bitcoin or EOS or Tezos or Ethereum or Hashgraph or anybody else. If more than a third of your population is evil, then they can do bad things.
But also the proof, oh, sorry, please ask what you wanted to say.
I was going to say, so basically your challenge is to just keep those kind of people from getting onto the network. Like I saw a product called Blockstack, where you have to pay a small amount of Bitcoin to join. And I thought even if it's not as open, it allows people to build decentralized applications on the blockchain. And it definitely can keep out bad actors by having to pay this like $30 charge or whatever to register an account on it.
Can I just say something for anyone else listening, and then you can answer, Mance? We're moving here into on non-permissioned networks, what we're talking about here, public stuff. So I just want to clarify that as well, but go ahead.
Yeah, so right, the market is split into two halves, right? There are the public networks that allow anybody that wants to download the software and participate as a full node. That would be the term, a full node. And this is what we're talking about. If not more than a third of the full nodes are evil, then you have some security. If more than a third, then you're out of luck. And that's independent of whether it's public or private. The question you're raising, on the private side, when I spoke previously, for example, about World of Warcraft, it may be that you and a dozen of your friends download the software and you stand up a network, and you're on the network, all of you are on your network, and you have the security that we're describing, and you're not paying for it. I mean, you are there, you're using your resources on your computer because you want the privilege of being able to participate in the game, right? And so in a permission network, there are other motivations for wanting to participate as a full node, and in each case, there will be some governing system that decides who can participate in that network or not. And in the public networks, it's just the opposite. It's open. Anybody that can participate that wants to.
So this brings us to a good sort of junction in the conversation, which is that you guys have had a lot of success on the permission side, on the enterprise side, and I do want you to mention a little bit of what you can about that, because it's kind of impressive, and I think it's important to note. And then I don't know what you can tell us about a public ledger, if you have plans for that. What you can or can't say, because obviously that's sort of either implied in the thoughts of many people that are either going to be watching this video or here, or they're consciously thinking about it, like this gentleman.
Sure. So the company is about 2 years old, and we raised our first money in Q4 of 2015. Went to work building the product. Ping Identity, a major identity player in the market, was the first money into the company. It was my organization that built the identity application within Ping on top of the first version of this technology. And that identity application has been proposed to the appropriate standards body to solve a technical problem in the world of identity. The OpenID Foundation is the standards body that I'm referring to. In November of last year, I moved over from Ping to Swirlds full-time and realized we needed market validation. Brand new technology, brand new algorithm. Nobody had heard of us. And we were making some really strong claims. I remember over and over and over, going in and saying to people what I've just said to you. And they said, no way, it's too good to be true, something's wrong. And so we had to have market validation. The credit union industry saw what was happening in the banking industry and decided they wanted to do the same thing. The industry wanted a platform for the 6,000 credit unions in North America that represent 105 million members to use. And I decided I wanted to compete for the business. And so I approached the industry and told them what we had. They said the same thing. No way, it's too good to be true. But we'll let you compete. And we competed. It was me and Lehman, a couple guys, competing with IBM and Hyperledger for the business, for the whole credit union industry. And we got to the first round of POCs, and in February of this year, we won. And then in May of this year, the industry decided to stand up a new organization. It's called CU Ledger, Credit Union Ledger. It's a new legal entity, a credit union service organization that is now capitalized and is about to announce its first CEO. You can think of it, if you're from the industry, it's the equivalent of R3 for the credit union industry as opposed to the banks. And that technology is being rolled out in the new year, and it's all built on the Hashgraph. And we won. We were able to win against Goliath based on the strength of the technology. Certainly not based on the size of the company or anything of that matter. We were able to demonstrate real value in the algorithm and the platform that we had built. And it solved fundamental problems that they were not able to solve with the existing platforms in the market today. And so we won that business. And since then, the pipeline has just swelled on the permission side. We're working with the largest banks, the largest payment processing organizations in the world, and we're addressing, real permissioned use cases.
Yeah. So I'll just jump in there quickly, and then I'll turn it over to Andrew. But it really is, the distinction I want to make is that Swirlds is the company that created the IP. And on that side, what we do, again, as Mans mentioned, is create or help companies use our tech stack to create private permission-based networks. So in these organizations, they're standing up their own nodes, and they manage them, and then they can build their vertical applications on that stack. That's different from what Andrew's working on here, and I think we can share a little bit more.
I'd love to know what it's like to develop on the platform, and how does someone get an SDK, and what's that process?
Yeah, that's a really good question. So we actually just went out to TechCrunch Disrupt, and the reason we were out there was to sponsor the hackathon. And this was a big what if for us. So we were really nervous that no one would develop on it. And we just put the SDK out there. Keep in mind, guys, we're a newer company coming out of stealth. We don't have fully built out documentation like a company like Heroku or Wikipedia or something. So as it turned out, in 24 hours, we had some amazing applications built, a real fully built out MMORPG. If you go to DevPost and just Google SF Disrupt 2017, you can see a bunch of these projects. The winner, we gave a prize to a team that actually built a distributed Sotheby's architecture where you could actually submit a bid via an SMS API called Hyphenate and submit a bid to the consensus algorithm, which would pick the winner. Accenture, who also sponsored the hackathon, actually gave their prize to a Hashgraph project who we also wanted to pick, but they had given their prize to a project called Ground Zero, which effectively used a mesh network type architecture to ensure that in a disaster like a hurricane, that the network would stay up and people could get an SOS signal out to emergency services. But you want to talk about the public side?
I won't. I mean, we haven't announced a public side yet. Everyone is so interested in the public side. It's so clear that this technology has massive implications for the public side. What was that gentleman's name who asked the security question? Hunter, your question is the most interesting question when it comes to public side. I mean, permission side, you can secure the nodes, right? But the public side, that's where it really counts. And if you just join our Telegram channel and wait a couple of weeks, I guarantee you will love the answer, okay? But I cannot talk about that right now.
So that is the most exciting sort of thing that I think everyone here is really jazzed up about learning.
I can say one thing.
Yep.
So one thing that is, I don't mind addressing at this point. If you have asynchronous BFT, and let me say what that means, at least in part. In blockchain, you never come to 100% certainty that the order of transactions will never change. It's probabilistic. With each new block that goes on top of the chain, the probability goes down that it's going to change, or that the coin that I've paid to you, the merchant, is going to disappear in some sense. With the hash graph, you have 100% certainty on the order of transactions, and you know for sure that they will never change. You have a math proof that you can take to a court of law that will stand up, right? It's not probabilistic. It's within a few seconds or less, depending on a lot of factors. You know for sure that the order of transactions will never change. It turns out that if that's the case, if you can have asynchronous BFT within a single network, a shard, if you will, then you can actually scale this in ways that the asynchronous BFT property, this incredible security, level of security, is maintained across the entire network in total, which is not the case in the existing platforms today. So starting with the very best building block in building your scalable system allows you to build a system in total that is unparalleled in the market, right? You start with the best bricks, you're going to get the best house. And asynchronous BFT is the key to that ability to scale.
And that point being, that's why the blockchain network can fork. The Hashgraph network cannot fork. I mean, the forking is sort of part and parcel of this whole thing.
That's a piece of it. That's correct. That's a piece of it. There are a number of issues that you have to address in order to have good governance of a public network, if we were talking about a public network. And the security is one of those. Another one is the ability to, having technical controls in place that make it possible for the governing body to actually govern. If it's the case that the governing body can't ensure or compel the users of the technology to adopt the changes in any meaningful way, then it doesn't matter what form of governance you have. I mean, in Bitcoin, we have bicameral governance with the core developers and the miners. In Ethereum, we have a benevolent dictator in Vitalik. And in both cases, we see chaos in the markets because the chains will fork into competing, or split into competing concerns, competing chains. And so, Vitalik made an interesting comment earlier this summer in a podcast with A16Z, paraphrasing, where he said, basically, the best that we can do to move the community forward is by taking advantage of each crisis as it occurs. That's what we have today in terms of governance. There are solutions to that problem, and we will talk about those in the coming weeks.
Yeah, and also, do you have a question?
Yeah, I do. So in Hashgraph, is every node a full node?
Yes. I mean, you don't have to be, right? I mean, if you wanted to have a copy of the hash graph or the data structure, but you didn't want to participate in the sense that you're gossiping transactions or storing information, et cetera, then you certainly could do that. You don't. So it's not like we have full nodes and partial nodes in sort of the traditional sense, but there's nothing that prevents a party from sort of being a passive observer of the hash graph.
Yeah, go ahead.
Okay, so for like the light nodes, how would the state updates to like that node be?
Yeah, well, so if a light node is simply accepting the transactions in the appropriate order, in the community consensus order, they have a local copy of the state. They just update their local copy of the state. They just aren't contributing anything, right? I wouldn't write to my local copy of the state new transactions for me in that sense if I'm a light node. I have a copy of the state. If it were a cryptocurrency, the state in this case would be the list of all the wallets in the population and their balances. That would be the state. And if you're a passive observer, you can see the transactions flowing in consensus order, and you take those transactions and you update the wallet balances as appropriate. And you would have a copy of the state that stays in sync even though you're not changing it directly.
Oh, yep, that gentleman right there.
How do you apply this to
Well, wait for the mic there so we can hear you.
So with Bitcoin, when you verify a transaction, it emits Bitcoins onto the network. So how would you apply this? How would you apply cryptocurrency to this? So you have this underlying structure that verifies transactions, but then what would emit new currency onto the network?
So I'm not going to give you the answer that you're looking for tonight. But I will talk about it briefly. I will talk about it briefly. From our perspective, I mean, what Swirlds sells is a consensus server. So in the same way that every company in the world today uses a web server, an HTTP server to serve up web applications, I expect that every company will, in the future, also use a consensus server to serve up distributed applications. A cryptocurrency is just an application. And so what we have is the ability for developers to create arbitrarily complex distributed applications using Java. There's no special scripting language like Solidity or anything else. You just use the full power of Java to build your application, and the platform handles all the communications and handles all the consensus. You have business logic. You have a database that stores the state of your system, whatever that is. In a game, it's the state of the world. In a cryptocurrency, it's the list of wallets and balances. And your business logic creates transactions, passes them to the platform. The platform gossips those transactions out to the entire community. The community comes to agreement on the order of transactions, and the platform then hands the transactions in consensus order back to your application, and you update your state. That's it. So cryptocurrency would be built on top of the platform in sort of the obvious way. And I don't mean to minimize it, but it's really not that complicated. It's not, I mean, Bitcoin codebase, Bitcoin blockchain codebase, everything's sort of smushed together, right? And in this case, we've got a nice layered architecture that separates the consensus and the communications out from the distributed application in total. The real question, though, that I think you might be getting to is how do you ensure, I mean, in a public network, how do you prevent something called Sybil attacks? Is that better? Thank you, thank you, thank you. How do you prevent something called Sybil attacks? In other words, how do you prevent for example, a state actor from standing up a bunch of nodes all at once and easily overcoming the 1/3 threshold that we talked about previously? It turns out there are ways to do that, and we will announce those.
So, can someone, Genevieve will bring you a microphone. One of the things that I would like to do is, because at some point I do assume you will be able to address these publicly, these concerns, and one of the things I would like to do is bring Lehman here to New York and put on an event where Lehman himself will appear and give you an opportunity to quiz him. And he can sort of explain all of that, which I think will be just super exciting and amazing and awesome, and I would be very excited to host that. Yes, please.
Yes, gossip, which is, I wanted to ask about how secure is it compared to PGP, the encryption? How clean is the encryption compared to PGP?
We don't create our own primitives, okay? So if that means anything to you, then you'll know exactly what I'm talking about. It is cryptographically secure. If I'm a node and I submit a transaction to the network, the gossip that we're talking about, what that means is that I am calling to friends and passing them the information. They are calling to friends and passing information, and this transaction flows through the population exponentially fast. When I pass the information to one of those friends, I am using standard crypto to ensure that the community knows that the transaction actually came from me and that it hasn't been tampered with. And so it's cryptographically secure using all the standard techniques that the entire industry uses. There are no new crypto primitives in our implementation. Yeah.
Yes, most of us in here are probably familiar with the revenue model that the creators of Bitcoin, Ethereum, and Ripple Network had in mind when they created their products. So can you talk to us a bit about the revenue model that Swirls has in mind as it relates particularly to the Hashgraph?
Yeah, well, so Swirls addresses the permissioned use case. And so Swirls sells those consensus servers to enterprise customers. On the public network, it's not the same. And the way to think about this, in one way to think about this, is that, and it depends on what you mean by revenue model. Let me touch on two things. When there is a public network, it will be the case that the participants in the network are all compensated for their participation. So the miners today, they participate in a lottery, right? And the miner that solves the crypto puzzle first gets paid a bucket of coins, and they get the transaction fees associated with the block. In this other model that we're talking about, all the people that participate in the network will get paid at a rate, sort of like a utility or maybe a salaried employee. They will get paid for how much bandwidth is contributed, how much storage is contributed, and how much CPU cycles, how many CPU cycles are contributed. And so there will be no ambiguity, right? If a 16-year-old kid stands up a node in their basement and runs that 24/7, they're going to make a certain amount of money. And if all goes well, they'll pay for their car payment with that amount of money, right? And so, but that's an entirely separate concern, legal concern, different company from Swirls, and so Swirls is not going to make Swirls is not going to make that much money from this public network. Is the point?
I want to emphasize that there won't be, this is going to be the intention of the creator. I wouldn't have gotten involved in this if we weren't going to create a public utility which was basically free for everyone to use. This is the thing that I think will change the world, to be honest. That's what interests me the most. There is a revenue model because you need nodes to verify transactions. But, and the other thing I wanted to mention is that because it's not proof of work, I mean, Bitcoin now is, I love Bitcoin, by the way, look, it is the forefather, right? But it is eating up 0.1% of the world's electricity. You can Google it. It's a huge, huge problem.
It's a humongous amount of
massive amount of energy, right? What if it becomes even more proliferant? What are we looking at? Like a couple of percent? You're looking at like that is going to contribute to the melting of global ice caps, et cetera, et cetera, et cetera. So this is why, one of the things that I'm passionate about is, to be honest, when people discover this technology or decentralized distributed ledger technology, they get passionate about specific things. That is one of my passions. And I was talking to Mike Maloney today, and the other passion is, Bitcoin, to Mike's point, is not a currency because I go on a tangent here just a little bit, but Bitcoin is not a currency because it's too slow, right? It's a store of assets, a store of value. But when you have something that's fast enough, then you can become a currency. At that point in time, then you can really help fix problems of hyperinflation or mismanaged monetary policy, et cetera, et cetera. This is what I believe. I mean, there is that application. That's the one I'm the most passionate about. I know my friend Sean is passionate about this, the identity side, and there are all sorts of other applications. But yeah, to your point there, that is revenue model. Swirls will charge customers, but on the public side, it will be to be announced, but there won't be licensing fees on the public side.
No, it's going to look very similar to what you're already familiar with, right? Application developers will build distributed applications, and when they make API calls, they will pay for those API calls with the currency. And there's no license. You just use the currency to make API calls.
There's a question.
Go ahead.
Yeah, I got a lot of questions. So, and I'm wearing two hats, an investor kind of hat and an engineer hat. So from an investor perspective, do you plan to have an ICO?
I'll jump in here. So the answer to that is no. We're not like anything else in the market. And in fact, I think we're very careful about that from the sense that what we're trying to address are much larger market problems, namely governance in blockchains that are out there today. So the short answer is no, we're not doing an ICO in the pure sense of what you see these ERC20 tokens being. So what we are doing is releasing eventually, and we'll share more information about that as we can, but a public protocol that you'd be building on top of.
Yeah, just an ICO, right? Initial coin offering. It is to build a protocol. Just deductive reasoning. Of what's out there in the public. If we've built this for credit unions, do we need to raise 200 million, 100 million, 5 million, 1 million, even like a couple of 100,000 to transfer it to a public network? Why would we raise that money unless we're trying to scam people? It doesn't, well, I mean, I guess you could use it to get people involved, but then you'd want, I want to give each of you $100 of allocation or something like that, But the technology stack was built. This is why when I discovered this, I was like, this is insane. Like, these guys are all raising 200+ million for this, and this guy from Texas has actually discovered this. Had to go down the rabbit hole to make sure it wasn't BS. But when I got to the bottom, I was like, I can't believe this actually works. And so to your point, will there be an ICO? Well, you just think about it, like, there doesn't really need to be one, I can't really say too much more, but you just, there'll probably be a sale of some sort of coin if a public ledger were to happen.
Yeah, and just one. This is okay. And just one more point to that. These ICOs, I think what you're really seeing happen, and this is just more of commentary on what's happening in the market, is that this is the evolution of venture capitalism. I think it's really important. Not all ICOs are shit. There's a lot of really great projects out there. What we've got here is not theoretical. It's not a white paper. We're not raising money to launch a project. We already have that. As Andrew mentioned, the tech stack is built. You can go download it right now, actually, on swirlds.com/download. You can download the SDK. We have 6 demo apps in there, fully built out, you can play with, you can take them apart. So again, I think ICO in the purest sense right now is to raise money or to distribute a token. We're not using it as such. Yep.
That's a great answer. The other question I have is about the tech side. So how the Gossip protocol is solving the CAP theorem as a consistency, availability, and partition tolerance? Because it's really similar, it seems like, to Cassandra, which is AP almost C.
Yeah, I always get these things mixed up. What I can tell you is this. If the network were partitioned, it would not come to consensus. Okay? So unlike Bitcoin in this case, just as an example, in Bitcoin, if the firewall, the Great Firewall of China, were shut down, then the populations on both sides would continue to operate, and the chains on both sides, would continue to grow, and blocks would be put on top. And if it were the case that an attacker could use their wallet on both sides of the chain, they would be able to spend their money on both sides of the chain. And in our case, the whole population has at least two-thirds of the entire population has to be available to vote, as it were, to come to consensus. And if the network is partitioned, then the consensus just stops until it's no longer partitioned.
Mance, the Hashgraph forms a sort of genealogical tree, right? Where you look backwards in time and you're able to get to a point where 2/3 or more, it's basically super majority voting, are able to verify that they're all seeing the same thing. How would you explain that sort of to sort of layer on top of what he's asking?
Yeah, so
the famous events, essentially, like.
Right. So here's the deal. The question is, how do you put the transactions in order? You have a graph, And the graph represents the gossip, about gossip that's taken place in the network. The transactions themselves actually just sort of go along for the ride. They're the payload in the nodes of this graph. And if you have a graph, you know, it's hard to, it'd be great if we had a whiteboard, visualize sort of a graph. You have two nodes that look like they're at about the same vertical location in this graph, and the community needs to agree which one came first. What we do is apply, or find, I should say, find a community timestamp associated with each node. And the way in which we do that is when I have a transaction and I gossip it into the network, when you receive it, you timestamp it. The received timestamp of that transaction. And the entire network, all the population of the network, they receive my transaction, and everyone in the network timestamps it. We then find the median timestamp, not the mean, not the average, but the median timestamp. And because we all are doing the same thing, we all come to the same conclusion about what that median timestamp is on the transaction. If every transaction has a consensus timestamp, we call this, by the way, the consensus timestamp. You know, the problem here is if I lie about the timestamp when I timestamp my transaction and then pass it into the network, you can't trust me. You can't trust me to be telling the truth. But we can trust that the community, assuming not more than a third of the community is evil, is telling the truth about the time at which they received the transaction. And so we find the median of the received timestamps, and that becomes the community timestamp on the transaction. Every transaction has a community timestamp. Once you have that, you just line up all the transaction in timestamp order. And that's the order, that's the consensus order of the transactions. What you were referring to is this thing called famous witnesses. And I won't go into the details of exactly how that works, but I will say this. What we have to agree on is what the population is, the population that's active at a point in time, in order to find the median timestamp. If I think that, you know, a certain portion of the population is active, and then I find the median across that active portion of the population, and you have a different view of what portion of the population is active, and you find the median for a given time, a given event, we're not going to have the same median potentially. And so we have to come to agreement for a given point in time, what is the active set of nodes? And once we've done that, then we are all going to come up with the same answer of what the consensus timestamp is on the event.
What if a node on the network gets knocked offline and then comes back online, let's say a few days later? How do you manage fairness in that scenario? How does that work on the Hashgraph?
So we talked about states, right? And the state of a cryptocurrency is the list of wallets in the non-zero balances, you know, the wallets and how much each wallet contains. It turns out that it's not that difficult for the community to come to an agreement on the state, a consensus on the state of the state object at a given point in time. And we do this regularly, periodically, frequently. And so if a node drops offline for any amount of time, any lengthy amount of time, and then comes back online, what that node does to sync back up is just ask any one of the other nodes, send me the latest consensus state. You know, the community comes to an agreement at a point in time on the state object. Send me the latest one of those. And once you have the latest consensus state, then you just take the events in the Hashgraph that have occurred since that community consensus state was signed by the community, and you update your local state object with the latest set of transactions. But what this means, if you have a consensus state like this, is you can throw away the part of the Hashgraph that's already represented in the state object. In other words, it's not like blockchain where you have to record everything, the entire chain from the genesis block on. you only have to keep the portion of the hash graph in memory that's recent since the last community-signed state object.
You can have someone with anterograde amnesia, essentially, walking around doing just fine. You can have Memento, the character from Memento. Essentially, you're talking about short-term memory. You're a fish, and you're able to dump that data all the time. You don't need to know everything that happened years ago because of the nature of the consensus. Because it isn't that you probabilistically get closer to consensus. You know that you're sure at a certain point in time, and you know you'll never need to look at it again, so you can dump it, is what you're basically saying.
That's right. So all of history is represented in the state. And the community comes to agreement on what the state looks like at a point in time. After they've done that, you can get rid of all the transactions that were reflected in that state, because the state implicitly already reflects all of that history.
This is a good opportunity, and we're going to go to you in a second, a good opportunity to plug Hidden Forces, because you should, if this is interesting in any way to you, and I think it is probably to everybody here if you're still here, you should listen to my interview with Lehman Baird, because we go into this in more detail in certain areas. And I've also published a transcript of that conversation, a consolidated transcript actually from numerous conversations that I've had with him on my website at hiddenforcespod.com, and you'll be able to see also links to Swirlds and Hashgraph and sort of what they're doing. But can we get that gentleman a microphone right there in the blue jacket?
Thank you. First, I want to say thank you. This is a really intriguing and expanding conversation. Really enjoying a lot of your analogies, and I'm happy I came. First, I have two questions. First question will be a little bit simpler than the second one, might be a little bit more complex. Could you give us, and I think that probably some people are computer scientists in here, but a lot aren't. Could you paint a little bit of a vision of 10 years from now? Let's say all your dreams come true and Hashgraph becomes the leading technology for distributed ledgering. What is the difference in somewhat of our daily human interaction for pretty much the average human, and what does it look like, and why are things so much better 1 decade from now if everything goes exactly as you would want it to?
Okay, I'll start. I'll do my best there. If you were to ask Lehman this, I want to try to do him justice. He'd tell you that 100 years from now, Hashgraph or some version of it would serve as the trust layer that sits over TCP/IP. The trust layer on top of which you've got a world of distributed applications that can do any number of different things, and most likely, things that we haven't even thought up. We've thought of a really great number of killer apps that would probably be built. I think by this time, I'm going to make the claim that you'll have multi-billion-dollar companies built on our tech stack because of what we enable, because of the property of fairness. That's just not possible in existing DLT technology. So I'm really excited for what that looks like. I think as a company, and what we will serve and what we'll introduce will be an answer to a lot of the volatility and lack of trust among the mainstream with current public chains. I want to be really careful here, because I don't want to sound like we don't like the Bitcoin core, or we don't like Vitalik and Joe Lubin. We love those guys. I think at the end of the day, we're all trying to push this new future of this new distributed web, this new decentralized infrastructure. And on that note, I'd say that we think that many chains will exist, and probably interoperability between both, including ours. But I think the dominant technology will win, and I think that'll be Hashgraph.
Hello. Yeah. I'm actually friends with Joe Lubin, and everything. I don't want to even claim that we're going to be the dominant technology. I don't think you have to, right? If we perform the function that I want us to perform, i.e. with throughput and fairness primarily, and security as a given, then what I see is, like I said, my passion is to obviously enable a whole bunch of use cases. The ones I can foresee now are like, distributed MMOs, auctions and markets, but going beyond that, to create a currency which can be used as a currency as opposed to an asset class that enables third world countries, or countries that have poorly managed monetary policy to rely on a standard of exchange that isn't manipulated by the government. Right? I come from Indonesia, so I have experienced that firsthand through my family, and that is something I'm very passionate about. And in terms of how the rest of the world works, you should talk to the other members of the team, or even we have a community on Telegram. I keep mentioning that, but who they all have different. They talk about things like what does Colin talk about all the time? Organic farming or something. Everything from like identity to organic farming to supply chain to all the stuff that blockchain has. But you add throughput and fairness, and it just opens up a whole new world of other stuff.
So I'm going to go a little bit deep. Okay. I think that this technology is required. When I say this technology, I mean distributed consensus as a category, is required for the Internet of Things to reach its potential. And what that looks like 10 years from now is that things are able to discover the services provided by other things and engage them in a market and negotiate the terms of the deal and exchange the value across the things. And identity is a core piece of this. And what's interesting is that when we talk about the world of identity, it's normally the case that we know the identifier and we look up the attributes associated with an identity. I have an email address, and if I want to log into a website or something, I'm passing my email address to the SaaS provider. They are then looking up a record associated with me based on that identifier, the email address, and there's a list of attributes there that describe me. When it comes to things, we don't start with the identifier. I mean, we do today because IoT has not grown up, but that's not the interesting use case. The interesting use case is when we are wanting to consume services provided by things. I'm driving my Tesla in San Francisco, and I need to find a charging station. Well, I don't know the name of the charging station. I need to look into a things services directory for charging stations that I can use, and that services directory looks in its directory of things and finds things that provide the service I care about, and I use a general query to query on geography and requirements, etc. In other words, something looks like SQL, and it returns then a list of thing identifiers, all right? Charging station names. And I then choose a charging station name, and I'm able to look up more attributes based on that. That does not exist today. And in order for IoT to scale, I want to be able to say which vendors in the market can bid on my business when my light bulbs burn out. Well, if it's Amazon and Walmart, for example, they need to be able to query what light bulbs have burned out in Texas, in some geography in Dallas. They don't know the name of my light bulb. But they do want to query, this particular set of attributes, and I should be able then to return that information, and I should be able to have it set up so that when they see it, there's a marketplace activity that takes place, and I get the best price, and they automatically ship me the light bulbs. All of that needs a distributed services directory that enables markets, which requires fairness, it requires throughput, it requires everything that we've talked about here tonight, and it's not possible to do it with Bitcoin and Ethereum as designed today. Okay?
So I think we're going to have to wrap this up. I want to say one thing, sort of my perspective on all this, and you guys have been touching on it in different ways. Why I personally am attracted to this technology, not Hashgraph specifically, but distributed ledgers and sort of distributed technologies in general. We are living increasingly in a world that is intermediated by layers of technology. And a world like that, if we want to exist in that world as we are, as human beings with agency and liberty, and if we value these principles within which we currently operate as human beings, if we want to be able to maintain that in a world in this technological future, doing it on a server gives us absolutely no security in terms of how we end up sort of living our lives. I mean, it's the classic sort of big brother case. And distributed systems are the way that we can sort of try to get there. Again, technology is imperfect, and this is not a thing. I'm not trying to suggest that this is like the solution, if there is any solution. I don't think that actually there is. I think it's a work in progress, but I think that is sort of why I'm attracted to it, and that's why I wanted to put this panel together, because I think these guys may actually have solved the problem of scale, which would enable the use of distributed ledger technology to enter the mainstream, and that would be a total game changer, not just in terms of the amount of money that would be saved, but just the disintermediation of everything in ways that would be really profound. And that's why I brought them here, and that's why I wanted as many of you to come and sort of pose questions, and that's why I want to do this again with Lehman in the near future when you guys have maybe some news to share with the rest of us. Thank you.